Okay, we're going to be looking at how to fix your position while taking into account the effect of currents. Okay, so when you are sailing out on the water's moving around and you might be in the effect of a current. So let's say you're in your boat, you've got your compass, you go, okay, I'm going to set my course for 60 degrees, okay, 60 degrees magnetic. I go, okay, I'm going to sail on my way. Now, your course isn't changing, you're still on 60 degrees magnetic, but there might be a current that's pushing your boat this way. So even though your compass is still showing 60 degrees, you're heading this way, you're actually sort of crabbing across. Okay, so where you intended to go in this direction, you've actually ended up in this direction. Okay, we need to be able to fix our position while taking into account the effect of these currents. So, fairly simple. Let's have a look. I've got my Wind and Manly map, and I've got a problem. Okay, so let's have a look at the problem. It says, current can take our boat off course by a considerable amount if we're not careful. Before satellite navigation and GPS, small craft had to be constantly aware of currents. In fact, all boats have to be constantly aware of currents. A lot of your bigger ships, if the GPS goes out, you have to be able to navigate through using the stars, taking into account currents, all of this manual fixing your position. So it's important to learn. Consider this situation. You sail from the tip of Wellington Point Jetty. Okay, so Wellington Point Jetty is here. So from here, and on a compass bearing of 327 magnetic for 40 minutes at 6 knots. While you were sailing at, I'll bring this down, while you were sailing, a 3-knot current is continually pushing your boat sideways at a bearing of 242 degrees true. Give you latitude and longitude of your end point. So let's look at the information we've got. We've got leave Wellington Point Jetty on a compass bearing of 327 magnetic, 40 minutes at 6 knots. Okay. While you're sailing, a 3-knot current is continually pushing your boat sideways at a bearing of 242 degrees true. Okay, so first thing I need to do is grab my heading, 327, do it here, 327 degrees magnetic, and we're going to put it on the map, which is true, so we're going to turn that into true, remembering that's plus 11. So we've got 3 plus 11 is going to be 338 degrees true. Okay, and then you plot that on. Okay, so, sorry, Douglas protractor, make sure your N is the right way around and your numbers on the outside are counting upwards. Go to the tip of the jetty, line up your grid lines so that it's parallel with the side, and we're going to plot, what was it, 338 true. Okay, so 300, 3, 3, 5, 6, 7, 8. 338 true. And draw a line. Okay. Now, you're somewhere along that line. Let's work out how far you are. Okay. 40 minutes at 6 knots. So, remembering again, our speed triangle. Okay. Distance is always on top. So we want how far we've gone. Distance equals speed times time, which is going to be, okay, 6 knots. 6 knots times, and we've got 40 minutes. We need to turn that into hours. Okay, so we're going to go, that's going to be 40 minutes divided by 60 to tell us how many hours that is. Okay, it's going to be 6 times 40 divided by 60 is 0.6666. Okay, might actually key this line into the calculator because it's going to give me a more exact answer than rounding to 0.666. Okay, so let's just key this line in. 6 times 40 on 60. There we go. 4 nautical miles. So, 4 nautical miles along this line. Let's go back up here. Okay, we're 4 nautical miles along this line. Grabbing our piece of paper. Let's get all of this out of the way. We're going to grab along the side, not the top, the side. Okay, 4 nautical miles. So 1, 2, 3, 4. And put that on our line. So starting in the corner, we are there. Okay. Now, we have a current pushing us sideways. The current that we had was pushing our boat sideways at, it's a 3-knot current, continually pushing your boat sideways at a bearing of 242 degrees true. Okay, so we're just going to treat that as a second leg of the journey. Okay, so we're going to plot a line of 242 degrees true. Now that's true, I don't need to convert it. Okay, from our location. Okay, oh, this is handy, it's right next to the side, so I can line it up easy. Okay, 242 degrees true. It's going to be 200, 2, 2, 3, 2, 4, 1, 2. Okay, draw a line. Where'd my rule go? There it is. Draw a line through that. Okay, and our current was a 3-knot current. Okay, so we have the same thing, distance, speed, time. Okay, over the 40 minutes, we've been pushed 3 knots sideways, so we've still got the same formula. 3 knots, 3 knots, 40, 60. Okay, so we've been pushed sideways 3 knots, which is 2. Okay, so we've actually been pushed 2 nautical miles off course. So we're going to go and grab 2 nautical miles. Remember, go to the side of the map, line it up. Just be careful with the Wyndham Manly map because this top one isn't a full nautical mile. Okay, so I always use the bottom corner because that's a full nautical mile. Okay, and it's lined up. 1, 2, 2. Okay, I need 2 nautical miles, and I'm going to put that on my thing. That is our actual position. Okay, so if I grab where's my little boat gone? Let's imagine what happened. There he is. Okay, you've put in a course of, okay, it was on our, I'll put it in here. Course of 327 magnetic, okay, and you're heading that way, okay, but at the same time a 3-knot current is pushing you sideways, so you've actually done this. You look as though you're heading in that direction, but the current is pushing you that way. So after the 40 minutes, you're going to end up here. Now the question says give your latitude and longitude. So we're going to put that there, and well, I'll get him out of the way. There's our position. Let's line up on the side, line up there. It's sort of going to be about there, isn't it? Okay, so that's 27, let's grab this, okay, 27 degrees, 25.2, it's not quite to the 0.4 there, 0.2, 0.5, okay, should we go 0.75? Okay, so 0.27, not 0.275, that's 0.2, 0.3, 0.35, sorry. Okay, so 27 degrees, 25 minutes, 0.35 minutes south. Okay, and then our longitude, I'm going to line up on this. That look lined up? Oh, that's like spot on. There we go. Okay, that is 153 degrees, 11 minutes. Okay, 153 degrees, 11 minutes east. And that's how you take into account the effect of currents when you're fixing your position.